been discovered that smog and other pollutants interact with molecules in air to actually enhance the red coloring of sunsets.
The colors of the sky result from sunlight interacting with molecules in the air, primarily nitrogen and oxygen, which cause it to be deflected in all directions, a phenomenon called the Rayleigh scattering. All wavelengths of light are scattered but are not equally scattered.
Rayleigh explains that colors with shorter wavelengths are scattered the most: violet, then blue, then green, and so on.
Of the colors that make white light, the reds and oranges have the longest wavelengths, and thus are least likely to be detected.
So debris in the lower atmosphere scatter out the sun's blue and green light, leaving just red, orange, and yellow light to survive.
As the sun edges toward the horizon, the light must also travel increasingly longer paths and scatter by more air molecules.
By the time the sun is in position for a sunset, the shorter wavelengths such as blues and violets have been scattered out, which only leave the warmer hues of yellow, orange, and red.
Also, to get a red sky, you need aerosols. Aerosols are solid or liquid particles suspended in the air that originate from both natural processes and human processes.
Also, some natural aerosols come from forest fires. Mineral dust kicked up by sandstorms and sea spray and volcanic eruptions have helped in the production of some of the most spectacular sunsets in history.
Aerosols are produced when molecules in the gaseous state enter the atmosphere and react with other chemicals. Like burning fossil fuels release sulfur dioxide into the air, which then turns into sulfuric acid aerosols.
But in a large city, you can ignore natural aerosol products for the most part because the number of aerosols produced by human activity far exceeds natural sources.
In cities such as Los Angeles that contain 8-lane freeways that are jam-packed with millions of cars, pollutants get released into the air.
Most particles suspended above cities scatter radiation, removing the cooler violets and blues and enhancing the red.
These different events can eject sulfuric acid droplets into the stratosphere. That's between 10 to 35 miles in altitude. These droplets can be swept across the globe, painting the horizon a deep red.
If the particle is small compared with the wavelengths of visible light, it will scatter short wavelengths, such as blues and violets, more than long wavelengths such as red.
Many man-made aerosols are small enough to meet this criterion, so they contribute to deep crimson sunsets of Los Angeles and other polluted cities across the globe.
There are some cases where the sunset has become too red and too saturated where viewers cannot even see the sun anymore. Aerosols may make a sunset red. Excessive pollution will also dampen the overall sunset experience.
In fact, the transition from day to night might be a whole lot more colorful and healthier without all that atmospheric smog. Who would have thought that something like atmospheric smog could create something so pretty like a sunset?